Okay, so good nearly afternoon. So I'm Alex Giladi, and I'm involved in Dash standardization since about 2009. And Thomas Stockhammer and I are going to give a general introduction to the Dash standard. Then Andrei Popov will give an introduction to the security aspects of the standard. And lastly, we'll have talks about the way Dash clients work and the way Dash integrates with CMAF. So in this talk, and I'll try to keep it a little bit shorter to catch up with the agenda, we'll cover the actual Dash spec, what is the main terminology, what are the things defined in the spec, and then Thomas will continue and describe the low latency and live aspects of the spec in more detail. So the Dash spec defines media presentation description MPD, which is the actual manifest format, and it defines segment formats. So first of all, what does the actual MPD say? What does the manifest say? It says what you can download, what are your options, and when can you download it, when can you download it and be guaranteed to succeed. So in terms of selections, what you can select is, for instance, codecs, bit rates, what HLS, if you're familiar with HLS, calls variants. Then what can you download? You need to be able to derive in some way the URLs of the segments you want to fetch from the MPD. And lastly, when can you download? This is something unique to Dash. You can list segments that are already available for download. You can list segments that will be available in the future, and you have a well-defined mechanism that says that you can download the segment successfully in this time window. So what is a media segment? A playable chunk of media that is addressable via an HTTP GET. And HTTP GET can include the range requests as well. So two more key terms. So I just mentioned the issue of resolutions, bit rates. So a single variant, a single stream with a given resolution and bitrate is called a representation. So it can be, for instance, a 30 meg HDR10 4K, and it's again equivalent to what you would see in the HLS playlist at the second level, the media playlist. So the next level is adaptation set. So this is a group of representations that provide exactly the same experience and can be switchable. So you can if you have more bandwidth available, switch up and get to a higher bit rate. You can switch down to get to a lower bit rate, and nothing will change. So you can have a 10 megabit and an 8 megabit. You can as representations within an adaptation set, you can have different resolutions, but for instance, you cannot have English and German audio in the same representation set. You will have very interesting effects switching at random between the two languages. Same often applies to Ultra HD, where you have different security requirements and other types of switching that can result in some optimal experience. So how does all of this come together, and what does the Dash spec define? So we have four conceptual parts. We have the access engine, which is responsible for bringing MPDs, bringing segments, parsing them, and figuring out what to do with this later on. So we have selection logic that is completely application defined. And for instance, this is something like please select the language out of the languages that are offered. Select the type of closed captioning you can do, and so on. So the result of this will be selection of adaptation sets. This is not defined in the dash spec. This is something that everyone who writes his own client needs to address. The second part is media engine. So this is what actually does the rendering. This is what actually does the decryption. And this is where the secure path for decoding of premium content starts. Again, not defined by dash segment. Last thing, dash access engine can provide asynchronous information, and this asynchronous information can be processed in most cases by the application, with a couple of exceptions we'll discuss later. Except for a few events that are defined in dash spec, this is something that is defined by the application, handled by the application. If you're familiar with AV Foundation, this is how you use ID3v2 there. So the spec only defines the dash access engine. And going on with terminology, as opposed to HLS's format, where this is just a playlist of segments, basically, since this started as a glorified MP3 player, here we have periods. A period is a part in time where you have a video with same characteristics, and different periods can be completely different. And an MPD can be viewed as a playlist of periods. And if you are doing VOD and you don't have any ads, you don't have anything different, you only need one period. You have a single period VOD. The illustration here shows a linear programming case where you have the main entertainment content, you have an ad break, you go back to your main entertainment content, and in this case, both parts of the entertainment content will be shown as periods, and each ad will end up being a single period. This way, there is no coupling between the formats. You can get whichever format of an ad you can, and you display it, provided that the client has the possibility of displaying it. So, a little bit more about multi-period MPDs. First of all, if you have multiple periods, every time you go from a period to the next one, you need to reinitialize. So reinitialization can be, for instance, things like requesting DRM license, doing a reinitialization of the codecs, and so on. So bottom line, this is expensive, and if you are continuing with the same content, especially if you have the same content in two periods that are one next to the other, you can declare them continuous, and then you don't need to do a reinitialization. You know that you will have exactly the same adaptation sets. If you're playing something, some representation, you can go and continue playing it. Nothing changed. So there are two things that you may want to pay attention to. First of all, Mpeg defines a supplemental property, basically a descriptor that lets you know that period X is a continuation of period Y, and this is one thing, and you have to have the common representations and common adaptation sets. The other part is annotational. You want to indicate what is what. So you have an additional descriptor, asset identifier, that can tell you this is an ad break with ad X. This is the entertainment content with let's say given either. Then you can say, for instance, here in period M1 and period M2, they have the same identifier. This way, you on the client side can know that you are playing exactly the same content. You are just going back to it. Now, another relatively esoteric thing about periods is Xlink. So what you can do is you can put a placeholder period that either doesn't have any content or has valid content which can be replaced. And the way you can figure out that something is a remote period is you look at the element and you see the Xlink href attribute there, and this attribute will have a URL. You will request. You will send an HTTP GET to this URL. You will get one or more periods. You will replace this placeholder period with whatever arrived. If nothing arrived, there was an error or something was invalid, then if you have valid content, this is your slate. This is what will play. And this is something that is very useful for one of the strains of Dash dynamic ad insertion. You can have an upcoming ad break as a remote period. You can go and put an SCT35 there, and then either at playback time or when you parse the MPD, you will request the non-remote period, and this will proxy to your ADS, to your ad decision system, and give you the correct periods. So we just talked about dividing the presentation into coherent parts. So this is one thing, but now you need to actually list the segments and tell your clients what to download. So there is, again, a simple way of doing playlists. This is extremely verbose, and in the vast majority of cases, it's completely unnecessary. And it is unnecessary because typically you use a naming convention. So Dash introduced templates when you have something very predictable. Let's say you have segments that are named segment 0, 1, 2, 3, and so on. So instead of listing all of them, what you can do is a glorified printf and just put a variable that says this is the number. Put the starting number. And I'll show this a little bit later. This is as trivial as a printf. Another better way of addressing is familiar to people who used to do old school VOD, where you had proprietary indexes. Comcast defined one of these formats. You can have a single file, and you can have an SIDX box or more than one SIDX boxes, basically parts of the segment or a sidecar file, and these provide you with exact duration and exact byte offset to everything. One of the nice things about it is that this lets you do a kept VBR in a more stable way, because your client always knows both the duration and the size, as opposed to trying to calculate this and to estimate this. On the other hand, this is something that is workable with VOD. It's problematic with live, because you need to keep changing your file in the CDN. So how does this physically look like? You have your segment, and conceptually you have an initialization segment. You have this index, and then you follow with these subsegments, which something that could have been a segment, but is basically within the same file and is described in this index file. Typically, what people use is an SIDX box that is in the very beginning of a segment, but it is possible to use a separate SIDX file This is what you have to use. For instance, if you have transport stream, this is the case of SCTE SIF. A recent addition to it defines a single stream file for a complete asset and a sidecar index file. But you can do this with ISO-BMFF as well. So going back to the glorified printf part, so this is an illustration how do you actually do this syntactically. You have these uniformly named segments, and you indicate, for instance, what is the start number. The start number happens to be 42. You indicate the duration, which is here 2 seconds in 90 kilohertz scale. You indicate the scale, and then you can go and you can download the segments one by one, and you know if this is dynamic, you know when they are available. Now, one point that people don't always see is that you don't have to have fixed GOPs and precise, for instance, 2 second segments. You can vary it, and if you vary it within reason, it will things will still work, and you will get better video quality by not enforcing a fixed GOP, but trying to align with scene changes. So -IF guidelines say that as long as UA are not more than 50% from your target duration, and B, you don't accumulate over time more than 50%, you're okay, and things should work just fine. Now, in many cases, you have an equal segment duration, and you want to express it precisely. And segment timeline, which is something that is similar to what used to be smooth streaming, gives you exactly this. You can think about it as run length coded textual index. So you are telling your client what is the duration of a segment and how many segments of this duration do you have. And with the time, as you request new manifest, you request new MPDs, you can go and update this. And in one more thing, so this often means that you can address things by time. So your file name starts with the start time of your segment, but you don't have to do it this way. The recent version of MPEG -spec lets you specify the number you are starting from as opposed to time. This sometimes makes things easier to handle. Now, typically with VOD, your presentation is static, nothing changes. You have a list of segments that you need to address this way or the other. In live, this is not the case. You don't really know what you're going to get. You don't really know when your ad break is going to be, and so on. So MPDs can be updated, and Dash provides 2 different facilities to do this. You can explicitly state how often do you want your segment to be updated, and this is synchronous, and this can be decoupled from the segment duration. You don't have to request the MPD every second. You can get an asynchronous notification from your server within the Dash segment. Please go and update the MPD because something may have changed. So the way you can do this is using Dash in-band events. As usual, this is another file format box. In case of TS, that can be carried in TS as well. That provides you with the information that tells you your MPD is valid till this point. So one key thing that we can have and this is one of the things that lets us do far less polling, is using templates that are predictive, that list things that are in the future. And in order to be able to figure out when they will be available, you need some sort of anchor time. So it's called availability start time. So last thing that I wanted to cover before handing off to Thomas is what are dash events. So we already mentioned them a couple of times. So events are blobs of time data. And in the vast majority of cases, the dash spec does not interfere with what is carried there, and this is something that is handled by the application and is ignored if the application doesn't have a clue what to do with it. There are a couple of notable exceptions. The most important of them is an MPD validity expiration event. This is what I mentioned. Dear client, please go and fetch a new MPD. And events, you can carry them in two different ways. One is within the MPD, you have an element that is a list of events, and every event element carries payload. The other way is putting a box at the beginning of your segment. This is completely decoupled from your media segment at the access engine. At the access engine stage, you can go and pass this information to the application. In case of validity expiration event, you handle this within the dash player and just go and request the MPD. And this is what it actually looks like as an illustration. SCT35. How do you carry it in MPD, and how do you carry it in the actual segment? So in one case, you have an event stream element, and you have base 64 coded SCT35. In the other case, you are embedding a box that contains information on when the event occurs, what is the event, and what is the duration of the event, and then it contains again the SCT35 section as the payload.